This is Geometry, Section 1.5, Exploring Angle Pairs. So we've already learned what adjacent angles are. We know that they are angles that share a side and a vertex, but have no overlap. So two examples that we're going to see a lot of adjacent angles. We're not really going to talk about adjacent angles themselves too much, but two examples of adjacent angles that we're going to see are complementary angles and supplementary angles. So complementary angles are angles that add up to 90 degrees, and supplementary angles are angles that add up to 180 degrees. Complementary and supplementary angles, usually when we see them, they are adjacent angles, but they do not have to be. So, complete and label the diagrams so that angle 1 and angle 2 are adjacent and complementary. So it gives us angle 1. Adjacent means that they have to share a side, so I'm going to say that they shared this side right here. Complementary means they add up to 90 degrees, which means they have to make a right angle. So if I want angle 1 and angle 2 to be complementary, I would have to draw angle 2 like that, so that they make a right angle together and that they share one side. Same thing for angle 3 and angle 4. I want them to be adjacent, and this time I want them to be supplementary. Supplementary means they add up to 180 degrees, which means that together they're going to make a straight line. So if this is the side that they are sharing, angle 4, I would just continue this other side of angle 3 so that it makes a straight line with angle 4, that angle from there to there. So using those new definitions, it says that G and Q are complementary to each other, meaning that they add up to 90 degrees. So if we look over here and see that Q is 40 degrees, well, I know they have to add up to 90 together, so if I subtract 40 from 90, I get that G is 50 degrees. G is 50 degrees. Then it says G and F are supplementary to each other. Supplementary means they add up to 180 degrees. So if G is 50, to find F, I would take that 50 away from 180 because I know that F and G have to add up to 180 total. So if I subtract that, I get 130 for F. So now F is 130, G is 50, they add up to 180 together. Same thing, Z and Q are supplementary, so we already know Q is 40. Same thing we did down here. Take our 180 degree total, subtract the 40 that I already have, and get that Z is 140. So F was 130, Z 140. Next example doesn't give us a picture. We're going to be incorporating algebra, which is what we're going to do a lot when we learn a new concept. We'll learn the geometry concept, and then we'll throw some algebra in there as well. So P and Q are complementary. Automatically, when you see that word, you should think add up to 90 degrees. So it tells us P is this expression right here, 8x minus 1, Q is 4x plus 7. So since I know those two angles add up to 90 degrees, all I'm going to do is take those two expressions, add them together, 8x minus 1 plus 4x plus 7, and set them equal to 90 degrees, and solve for x. So combine my like terms, 8x and 4x, 12x, negative 1, and 7 is positive 6, equals 90 degrees, subtract 6, 84 equals 12x, and finally divide by 12, x would equal 7. So now that we know what x equals, to solve for angle P and angle Q, the measure of each of those angles, we're going to take our 7 and plug it back into those two expressions. So 8 times 7 minus 1 would give us 55 for P, and 4 times 7 plus 7, 4 times 7 is 28, plus 7 would give us 35 for angle Q. Once you've solved for angle P, you could just say, all right, well, I know these two angles are complementary to each other, so if I take 90 minus angle P, which is 55, I would get 35 for angle Q also. Two other concepts, a linear pair. So a linear pair are just adjacent angles that make a straight line. And since they make a straight line, they're always going to add up to 180 degrees. So a drawing of what this would look like is if we had a line like this, and then we had another ray cutting that line to make two angles, angle 1 and angle 2. Angle 1 and angle 2 would be considered a linear pair. And since we know that a linear pair adds up to 180, we could write that the measure of angle 1 plus the measure of angle 2 equals 180. Vertical angles are a little bit more complicated. We're going to see them a lot this year. So vertical angles are two angles that share a vertex and their sides are opposite rays. So what I mean by that is if we've got a point right here, we make a ray. An opposite ray would go like this. Then if we do the same thing from the same vertex, draw a ray, and then an opposite ray, this angle and this angle, angle 1 and angle 2, would be considered vertical angles. An easy way to remember vertical angles is that they make an X. They make an X shape when we look at them. Also, another super important thing to remember about vertical angles, just like a linear pair always adds up to 180, vertical angles are always congruent to each other. So our fact here would be that angle 1 is congruent to angle 2 because those are vertical angles. We could also talk about the angles on either of these sides. If I called this angle 3 and this angle 4, these two angles right here, those would also be vertical angles. They don't necessarily have to go up and down. They can be across from each other like this. So 3 and 4 are vertical angles, they're congruent to each other. 1 and 2 are vertical angles, they're also congruent to each other. So using that, name all vertical angles and all linear pairs in these diagrams. So 1 and 3 are across from each other, they make an X, so angle 1 and angle 3 would be vertical angles. Same thing for angle 5 and angle 8. Those are also vertical angles. They're across from each other and they make an X. Linear pair, we've got a bunch here. So we've got angle 1 and angle 8. I'm just going to write the numbers here. Then we've got angle 1 together with angle 5. So 1 and 5. Then we've got angle 5 with angle 3. That makes a straight line. And finally, we've got angle 3 with angle 8. All of those pairs make a straight line, so we call those linear pairs. Let's do linear pairs for this, and then we'll come back to vertical angles. So these two angles right here, angle 7 and angle 2, make a linear pair. Those make a straight line. And angle 2 and angle 6 also make a straight line. These three angles together right here make a straight line, as well as these three angles, 4, 9, and 7, make a straight line, but those are three angles together. In a linear pair, the word pair means two, so we only use two angles for a linear pair. Vertical angles for this. So we've always got to look for an X when we're talking about vertical angles. So here I see two lines and then this ray right here. If I look at these two lines, angle 6 and angle 7 are directly across from each other. Those are vertical angles. Then I've got angle 2, but directly across from angle 2 is angle 9 and angle 4 together. So angle 4 and angle 2, a lot of people would be tempted to say that those are vertical angles. However, this side right here of angle 2 is opposite from this side of angle 4, but this side of angle 2 is not directly opposite from this side of angle 4. So those don't make a perfect X. That's why we can't call those vertical angles. They would not be congruent to each other. Jumping down here to the practice problems, using what we just learned. So if I'm solving for these two variables, V and W, if I look at this diagram, I can see that these two angles form a linear pair. Therefore, I know that these two angles together have to add up to 180 degrees. They make a straight line together. So to solve for V, I could say that 100 plus that other angle of 5V equals 180 degrees. And then I just use this equation to solve for my variable of V. So I would subtract 100, get that 80 equals 5V, divide by 5 to get that V equals 16. I could do the same thing to solve for W. I could figure out what this angle is by plugging in 16 for V. A lot of people would be tempted to say, well, 5 plus 4W equals 180 degrees, but that's incorrect because this angle right here doesn't actually equal 5 degrees. It equals 5V degrees, so I would have to multiply 5 and 16 to get that angle right there. A simpler way to do it would be if I said, well, this angle right here and 100, this angle right here, are vertical angles. They make an X together. Therefore, I know they're congruent to each other. So 100 would equal 4W, because when two things are congruent, that means that they're equal to each other. So I divide by 4. 100 divided by 4 means that W equals 25. So we've got to keep straight vertical angles and linear pairs, because linear pairs add up to 180 degrees. Vertical angles are congruent to each other. We've got to keep those two things separate and make sure we don't confuse one with the other. Letter B over here, we've got two variables. We've got an A and we've got a C. So we need to solve for one first before we can solve for the other. Since we've got an A here and an A here, let's solve for that one first. So if I look at this angle and this angle, I see that those two things are vertical angles. So like we did before, whenever you see vertical angles, take the two things, set them equal to each other, and solve. So 8A minus 4 equals 5A plus 26. Get all your A's on one side. 3A minus 4 equals 26. Add the 4. Divide by 3. A would equal 10. Now that A equals 10, plug that back in. So 8 times 10 minus 4. This angle would equal 80 minus 4, or 76 degrees. Now I know what that angle is, so I can compare these two angles, this angle and this angle. I know that they make a straight line together, so I can say 76 degrees plus 13C would add up to 180. Solve your equation. So 180 minus 76 equals 4. 4 equals 13C. No, I'm sorry, this equals 104. There we go. Divide by 13, and you would get that C equals 8. Last concept for the lesson is the concept of an angle bisector. So in this diagram, because AN, that's a ray, it splits this angle in half into two 40-degree chunks, so two equal pieces. We call that an angle bisector. Angle bisector. We hear the word bisector a lot. Bisector is just something that cuts something else in half. So an angle bisector cuts an angle in half. So we're going to put, we call them rainbow marks. Different people call them different things. I call them rainbow marks. You'll see why when we talk more about angles. So you just make two curved marks on each angle to show that these two angles are congruent to each other. Just like for segments, we put a tick mark on the segments to show that those are congruent to each other. So an angle bisector is a ray that cuts an angle in half. So using that, in this first diagram, we're given that AF is the angle bisector of angle TAN. So this thing cuts this angle into two equal pieces. We don't know what those pieces are, and we're asked to solve for each of those angles. So since we don't know what they are, but we know they're the same thing, call them each X. So if I look at this diagram as a whole, I see that these three things, these three angles right here, add up to or make a straight line. We know that a straight line is 180 degrees. So if I take those three pieces and add them together, I can set them equal to 180 degrees. So 70 plus x plus x, x plus x, if I combine those, I get 2x equals 180. Just continue solving the equation. Divide by 2. So x equals 55 degrees. Each of these we set as equal to x, so each of these angles is 55 degrees. And finally, same thing, but now we've got two expressions, and it says that ON bisects angle DOT. So this thing is cutting the big angle in half, which means these are two equal pieces, so set them equal to each other. Get all your variables on one side. Y plus 10 equals 20. When I subtract the 10, I'm going to get that y equals 10. If I plug that back in, 4 times 10 plus 10, 40 plus 10 would give me 50. Since this is an angle bisector, each of these two angles have to equal the same thing. So these two right here, TON and NOD, are both 50. The entire angle DOT would have to be those two things added together, or 100 degrees.